Okay guys, this is video number 2 of the ones that you guys have to watch. This will be about the white blood cells and then the platelets. Alright, white blood cells, abbreviated WBC, also called leukocytes. White blood cells float around your bloodstream. They are good for your immune system, but they have to be able to get out of the blood, of the capillaries, so the blood vessels, in order to help you. And they do that by a very particular type of movement we call diapedesis. So D-I-A-P-E-D-E-S-I-S, okay, which is what this little portion right here is showing you. Okay, this green is a small capillary, and these little cells are able to sneak out when needed to get to locations that are needed when they need to help fight infections. So again, that is done by that term, diapedesis. All right, so let's take a look at a typical white blood cell. All right, so this is this little guy right here. It does live only about 12 hours, right, compared to about 120 days for the whites that we talked about in the last video. It is 12 hours. What it does is it's going to kill foreign invaders. So here we can see, right, a little bacterium, okay, and this is a little virus, so it does help to kill some various things, and we'll talk about each of the little subsets. All right, there are a couple of things that help to increase the number of white blood cells in your bloodstream. And the things that help to increase the number of white blood cells coming out of your blood vessels or going through diapedesis are these little chemicals we either call interleukins, or ILs for short, and there are several of those, or of this other little purple line, okay, that has a blank, colony stimulating factors, or CSFs. Okay, so those two chemicals that are produced inside your tissues when they are damaged, okay, help to increase the number of white blood cells and help to increase, okay, how they get out of the capillaries. Okay, let's talk about the different subsets of white blood cells. So there are two major categories of white blood cells. They're either called a granulocyte, okay, here, or an agranulocyte with that A prefix before it. And granulocytes just mean that the background appears very dotted and like there's little grains in the background, whereas agranulocytes appear very smooth, okay, in their background. So let's take a peek at that. Okay, so this is an example of a granulocyte, and you can see all those little grainy-like appearances that are towards the background. Okay, here's another one we'll talk about again, the grainy-like appearances towards the background. Okay, versus your agranulocytes, when you can see that there's a clear nucleus, but, okay, towards the background, it is nice and smooth. Okay, so you don't see those little grains like you do with granulocytes. All right, white blood cells can be easily picked out of a set of slides because it does have a nucleus. And one of the interesting things about white blood cells is that they kick their nucleus out before they're put into the bloodstream. So red blood cells don't have a nucleus, but white blood cells do. So let's come back to this picture, and then we are going to look at our 3 types of granulocytes, those little greenies. Your most common type of white blood cell is a neutrophil. Okay, it is a granulocyte. And you can see here I've drawn a typical neutrophil, although you guys will not have to do them underneath a microscope. But it looks like it has multiple nuclei. Okay, it's easy to distinguish those underneath a slide. Neutrophils account for about 54 to 62% of all your white blood cells. And they are really, really good at fighting bacteria. This little picture right here happens to be a bacteria. All right, your next granulocyte is an eosinophil. Okay, this is an eosinophil here. It only accounts for about 1 to 3% of all your white blood cells. And in particular, these are the ones that we find in anaphylactic reactions and helps us to fight against parasites. Our last granulocyte is a basophil, okay, right here. It is less than 1% of all of your white blood cells, so it should be the least numerous source. And this one actually produces our 2 H's. Okay, histamine is the first one, and heparin is the second. And histamine is the stuff that gives us our allergic reactions, right? So when we think antihistamines, things like Benadryl, Sudafed, right, they stop the itching, the watery eyes, the redness, the sneezing. Okay, so histamine is what is causing all of that, and that is produced from the basophil. The other H is the heparin, okay, which is a blood thinner. So having too many basophils, okay, inside your bloodstream would be extremely bad because you would not want to thin out your blood too much. All right, there are two types of agranulocytes, those nice smooth ones in the background. And the first is a monocyte. The monocyte is the largest by size. It's a very large cell, and its nucleus kind of looks like, it always reminded me of a little bit of a Pac-Man shape, and that's pretty much going to give you a clue as to what it does. It accounts for about 3 to 9% of all of your white blood cells, and it is what we call a phagocytic cell, meaning it comes along and it actively eats foreign particles. All right, so hence that nice little open appearance of the nucleus. It sort of ingests it and takes it towards the inside of the cell. All right, your second type of agranulocyte is a lymphocyte, and there are plenty of subcategories of lymphocytes that we'll talk about with one of our future chapters. But lymphocytes account for about 25 to 33% of all of your white blood cells. And these ones in particular help to fight off viruses. So you can see that your two most numerous, right? Your neutrophils, which fight off bacteria, and your lymphocytes come in number 2, which fight off viruses. And those are the two most common things that you're going to find out there in the world and that we have to fight against. All right, two disorders you need to know about are right here on the side. And Leuco Cytosis, right, is too many white blood cells, which doesn't seem like it would be a problem, but certainly would create an overreaction of the immune system. And leukopenia, which is too few white blood cells, in particular, would cause a lot of immune issues. All right, let's take a look at the platelets. Okay, this is just an overview of platelets. All right, and platelets are actually not even full cells, right? So red blood cells have no nucleus, and they're that biconcave disc. White blood cells all have a nucleus, and they're either a granulocyte or an agranulocyte, and we just talked about the 5 different subdivisions, of the white blood cell. But platelets themselves are not a full cell. They're actually a cell fragment. So they're actually a broken up cell from a very large type of cell that we call a megakaryocyte. So megakaryocyte. Okay, so this very, very large cell will break up into little splinters, giving us our platelets. Platelets, of course, are also known as thrombocytes. A good number of them to have is between 150,000 and 350,000 for every millimeter cubed of blood. Okay, the main function of all, of your platelets is to do homeostasis, or hemostasis rather, which is really to help us to clot, right? Because you don't want to have a cut and simply continue to bleed forever. We need to have some sort of a process by which, we are able to stop that, and platelets is that process. So let's take a peek down below at just some of the basics of this process, and how that works. All right, so first step, of course, is to have damage to the blood vessel, right? So you can see here, we've got our red cells, and we've got these little green dots, which are, our little platelets floating around. And again, they're cell fragments, they look awfully small. So let's say you cut yourself, do some damage. If we didn't have any way to stop this was going to open. We're going to have damage, and all of these blood cells will just continuously keep flowing out, which would create a problem for us. All right, but the good news is that damaged tissue starts to release chemicals, that attract these platelets. And in particular, I have shown some of this, and this is what platelets actually release. All right, so step number 1 is that the blood vessel is going to go into vasospasm. So following the damage, vasospasm is going to occur, and you can see that the damaged end is going to try to pinch itself off, and for small blood vessels, this will work really well. All right, so this is just the attempt to sort of stem the slowing. All right, the chemicals that the tissues released are going to attract platelets, and they're going to try to stick right over the ends, here to even further, stop the release of these red blood cells and other cells, from simply just leaking unchecked into the tissues. The platelets themselves release serotonin, which is this little molecule, that we traditionally think of in the brain, but works for platelets. And this will help to attract even more platelets down to the site of damage. So it's really a lot of chemical signals, that's coming through that's going to help attract the platelets to that damaged area, create that vasospasm, and hopefully reach to this final stage where you've got platelets totally covering the damaged sides, okay, and forming what we call a platelet plug. Okay, if we form the platelet plug, we can then go on to repair the tissue, reconnect both sides, and everything is great. Okay, but the vasospasm and the platelet plug, you're only looking at about 30 minutes before the blood vessel starts to relax again. Okay, so this has to happen relatively quickly. Okay, this obviously works much better on smaller vessels than it does on much larger vessels, just for size comparison, right? I mean, if the platelets have to attach between the gaps of where the damage is, it would make sense that smaller vessels, okay, are much more easy to create a platelet plug than a much larger blood vessel. All right, so when we meet in class, okay, we're going to be talking about coagulation, so larger, okay, platelets and stopping of blood. Okay, so what do we do when we have damaged larger areas? And we're going to be talking about blood transfusions. Okay, so see you guys next class.